Elementary statistics, looking at section 8.3. So if we open up to where 8.3 starts, we're on page 413. We're talking about testing a claim about a proportion. So basically, if we're trying to figure out what's the percentage of a population doing right here, how are we going to test towards that? Okay, so they have some guidelines set up here. Where we start talking about our objectives. Conduct a formal hypothesis test of a claim about a population proportion P. Notations: N is our sample. P hat is X divided by N. Once again, X would be our successful trials, N would be then the number of trials or the number of people in here. P then would be the population proportion. Q would be 1 minus that. Okay, so once again, the note between P hat and P has a difference in here. Please realize we have some requirements going on here. So we have to have a simple random sample of what's ever going on here. Conditions should follow a binomial distribution. Either we're falling into one category in this population or not. For instance, we talk about people greater than age 60 or not greater than age 60 would kind of be how we could fit this in here. And then also remember that we have N times P is greater than or equal to 5, N times Q is greater than or equal to 5 for what we're referencing with towards that population. The binomial distribution of sample proportions can be approximated by the normal distribution, once again, that mu equals NP in here, so that could also be a descriptor in here. Please remember, because we're talking about a population proportion, we will be relating to a z-score in here, where we take P hat, our sample proportion, minus the population proportion over the square root of here. Now do realize this population proportion might not be the true population proportion, but it's going to be what we're testing towards. Okay, so once again, disclaimer, do not confuse p-value with the proportion p. They are different in what we start using in here. So they give a bunch of methods in here and steps. Okay, so do realize step number one, so I'm going to kind of come over here. Step number one, what is the original claim? Okay, what's the original claim? What are we relating towards? And then what's the opposite of that claim? Okay, because once again, remember, one of these is going to be the null hypothesis, and one is then going to be the alternative hypothesis as we go. We're going to deem our significance level that we start working through, and then or our test statistic as we're going through this, and then we're going to start testing that claim. Once again, this is using a critical value method. I will be showing you how we could do this faster with the calculators within this section. Do realize calculators are not perfect and don't work all the time everywhere. Okay. Part 2 here, they also talk about the exact method for testing claims about a population proportion P. Notice that instead of using the normal distribution as an approximation to a binomial distribution, we can get exact results by using the binomial probability distribution itself. So once again, looking at that left tail, right tail, two tail, ooh, make you dizzy. Left tail test, p-value is a probability of X or fewer successes in N trials. Right tail, X or more successes. And then once again, different approaches for that two tail. Once again, depending upon how we're looking at it. Do we want it to equal 1, or are we stating equal, which we don't want it equal to something, so that not equal. Okay, this kind of sums up the notes for this. I know it's rather short. The first section kind of went through all the steps on the null hypothesis, one tail, two tail, and find some stuff. In this section, we're really going to dive into the actual application and finding our confidence intervals.